So thank you, Vitaly, for making possible this talk in nice city Odessa. So I am from IGH University of Technology. This university is in Krakow. So my research is connected with computer vision for several years, machine learning, pattern recognition, robotics also, including humanoids robotics. So every year I supervised a few international students. This year, for instance, I supervised students from Thailand, Mexico. Now I supervise students from Kazakhstan. So from time to time I speak Russian. So if you want to visit my lab, please apply. Every year my department supports students. And I also have grants. One of them will start this year, and it is related to grasping, object grasping by robot. Computer vision, machine learning also, so it is quite interesting and emerging topic. So we start with simple approach, and then we move to a little bit more complicated. So previously I said you that in neural network, one of the most important factors is data. So here we recorded a relatively big collection of training data, but we use also geometrical models. In Blender, for instance, this hand model was developed to generate additional data. In order to obtain good model, we need data. And we recorded natural images, but we also generated millions of training images using geometrical models. And we obtained here very good parameters, even with simple neural networks. So learning of such neural network is quite easy. If you have enough data, then so accuracy was here quite good, 97%. Okay. And here the next problem we considered recently. This is personal identification. So the problem is that here we have one person in one camera, and we have the same person in another camera, and then the problem is to re-identification of the person. Okay? And here, naturally, one of the approaches is to use handcrafted features to extract some features. Okay, as you see, the change, the change in view can be considerable. This is the same person. Okay, and our goal that if we have such person seen previously, our goal is to recognize or to say that it is the same person in different camera. So typically the problem is solved that here we have gallery of images from, say, camera D. We perform feature extraction, and then we have good invariant features. Then given some unknown person, we extract features, calculate some similarity measure, and then we formulate ranking list. Ranking list expressed as similarity. And here, as I said, this is quite a complex problem because before person identification, we should perform person tracking, feature extraction, and so on and so on. And this problem naturally can be solved, as I said, using classical features, but also using features extracted by neural networks. And we done such task. So here I explain you distance metric learning. So the idea is here to find a function for which similar features will be close in some high dimensional space, and far away features will be not close, will be also far away in some space. So my approach was to use Siamese neural network. Siamese means that we have a neural network in which the weights are shared. Okay, so here we have some some const function, and we naturally training neural network. Our goal is to find a set of parameters for which this cost function assume the smallest value. I also trained triplet neural network. So in Siamese neural networks, in one step you submit positive the person of interest and positive example, and in the next step you submit person of interest and negative example. But in Siamese neural network you have image, here is positive example and here is negative example. That means that you have 3 copies of neural networks, and each neural network shared the weights. And now I propose here an architecture consisting of based on Siamese neural network, and as you see here we have hierarchy of features. Because here we have neural network which represent the whole image. This image, as far as I remember, represents the upper part, and this image represents the bottom part. But we experimented also with more complex structure. So the idea is here that we try not only one network, but several neural networks on several parts of the input image. But here, as you see, it is integrated framework. So that means that we do not train one neural network or some collection of images, and then second and one. No, here we train all neural networks in one complex framework because the cost function is common. One cost function at the end, and here naturally each triplet or Siamese neural network has own cost function. And we obtained very, very good results in comparison to top results published recently at topic or top conference or journals. So here you see the features extracted, but by such Siamese or triplet neural network. As you see here, this is the two-dimensional representation of feature. As you see here, similar features. For instance, here you see that the red color are close together, are close each other. And if you look closer at this image, you find here similar structures. For instance, here, as I see, is a little bit similarity, and so on and so on. So it was a goal. Okay, try neural network to extract features. Okay, and now you see here a two-dimensional representation of features. And we are, my group, we are working also on histopatological images. Here is an example of such image. So here, this size is 5 millimeters. And this image, for instance, is 1.8 gigabyte in size. Okay? And our goal is to extract or recognize, for instance, cancer. Later, maybe, if Vitaly give me 1 minute, I show you such image in viewer. Unfortunately, I connect to my server because here previously it worked, but now it does not work because of problems with connection. Here you have example of such histopatological image in zoomed. So here is our area of interest, okay? And here is this area, this small rectangle. And here another example, okay? So we are working in fact on such zooms. So here it is probably one single point of this area. And this, the size of this image, maybe it is 1,000 pixels, like times 100. And this area, this is 25 micrometers, okay? So maybe I switch now to real viewer. Oh, yes, I have. Okay. So we are working on such images. Okay. to, yes. So we have a data set. That is the more important part in this research, data set. This data set at the moment consists of 40 scans, and the scans were annotated by medical doctors, but in the future we expect that we will have thousands of scans annotated, because it is several years approach, and we expect that we will have plenty of scans, maybe even thousands for Klaus. So at the moment we extract patches of size 250 size times 256. Naturally, we started with transfer learning using VGG, neural networks, AlexNet, ResNet, and so on and so on. And we obtained quite promising results. We also trained Shamese neural network. I explained you in this person identification approach. But as I said, we are able to train deep neural networks similar to VGG from scratch, so from the beginning. Naturally, training takes place weeks, even months, depends on the computer, but we are able to do this. Naturally, the best results were obtained by some hierarchy or ensemble of features. At the moment, we have 85% classification accuracy, but we expect that it will be larger. It seems that at the moment, the system is better, delivers better results than typical medical or pathologies. So that's all.
Thank you very much, actually. So this is some practical results. I have just one question from me. Like, do you have some cooperation with some medical institution, and how they provide you data? So because this is, or you do this, I don't know, by some other. Because we have some companies in Ukraine who doing kind of similar, and they have access to a national institute, for example, and of something, and they provide data. So how are you dealing with this? So
this is commercial project.
How to get data cheap?
So we have scanners, the best scanners in the world. Hamamatsu is maybe the best. So the good news is that we make public data. We expect that for each class, so for 3 or 4 classes of cancer, we put data from 100 of scans, and each scan contains even thousands of million patches. So very, very big, maybe the biggest data set will be available.
So
I don't know when.
So this data set available and
will be. We are still working
okay.
on that. At the moment we have 40 of scans, but data set, naturally we will have very, very big data.
Okay.
Because it is commercial product, and but we make public considerable part of this data set.
Okay. And it's sponsored by some commercial company or some grants from European Union?
Yeah, it is grant sponsored by Polish National Agency, but it is this grant is made by a commercial company in Poland.
Okay. Cool.
But what cooperation is welcome. Welcome because this project has a research part, so we are open for possible connections, collaborations, and so on and so on.
Okay. Questions? Yeah.
Thank you, and I have a question about working with pedestrians. The most classical approach to this problem is to use histogram of oriented gradients plus a support vector machine. And in this case, we have as a result of training, a support vector more than 3,000 of values. It seems quite enough to compare the distance for image of person which are under suspect of the same person. Why don't you use this classical and famous approach?
No. So this talk is focused on on machine learning. But in my opinion, machine learning, it is only, this deep learning technique is only a stage. In the future, in my opinion, because at the moment, now, the best result we obtain if we fuse handcrafted features with deep learning features. Naturally, when we submit a paper to journal, then some reviewers say, wow, it is impossible at the moment. The best results are obtained or are delivered by deep learning. Submit us more results and so on, but because we do not believe. But in fact, we obtain. It is, and therefore, even in person identification, naturally, we extracted here some informative features. Okay, here is the visualization, naturally, but then we fuse such features with handcrafted features, including histogram of gradient, because histogram of gradient is good description, especially gradients are not dependent on light conditions and so on and so on and so on. And this talk is only focused on deep learning, but we fuse. The future belongs to fusion, because we cannot say that all handcrafted features are useless no. Some of them are very robust. We cannot ignore fast Fourier transform and so on. And the whole theory is no.
Okay, more questions? Oh, good, we have a lot of questions. So you see, I save time, and now we have 7 questions. So we will have very...
Thank you for your presentation. Could you please switch to this slide about the cancer? The next one, I believe.
This?
No, after that. So basically, I have 2 questions. The first one is, how many patches did you have in your data set with cancer?
How many?
Patches. So you had 40 scans, but and then out of those 40 scans, you had several patches.
So this image is 1.8 gigabytes. And if we extract here patches 256 times 256, then maybe it will be area like this. Thousands or even thousands or dozens of thousands of features from single image. So medical doctor, I cannot show this because I have at the moment no connection. So this slide is not annotated. So typically medical doctors say, here is cancer. Here is cancer of probability and so on. Or here is Gleason level, for instance, 1. Here is Gleason level 5. So here we have such the whole or almost whole slide annotated by medical doctor. And here is plenty of areas.
Yeah, and you almost started answering my second question, which is, what is approximate distribution between patches with some tumor in them and the patches without any tumor?
Yeah, so the problem of unbalanced data is here considerable. Yeah, it is one of the most important problems here, and we are doing research in this area.
Is it 1 to 100 or
no,
approximately? What is approximately?
Depends, but this range, it can be this range, yeah. Yeah, it can be.
Okay, thank you.
But my question about labeling, it's requires some to do labeling by doctors, some certification?
Medical doctor, so professionals.
So it should be professional with a certificate. Okay.
Even we are doing the diversification, so some slides are annotated by 2 different doctors, and we see considerable
so you're trying to
difference.
See difference in
even medical doctor said that 50% of difference between one and the second doctor can be.
Okay, cool. Wow.
Yes, my question will be about the confidence measure. So since this work you're talking is really important for the patients who want to have a test whether it has cancer or not, it's quite important to know how to measure the confidence of the results. So for example, if your network predicts that for this particular patch there is high probability of the cancer, how confident are you, and what confidence measure are you using for
that is important problem, but here is statistical approach. So typically for medical doctor, one wrong cell, for instance, this fragment is sufficient to say that is scanned with cancer. but we take different approach. It is statistical approach. So decision is taken not on the basis of one scan or one decision, but typically here we have several outputs of neural network, and as I said you previously, each because of softmax produces probability. Then we perform analysis of the probability distribution and
Thank you. I have a question about fingers pose. You said that you have generated from the Blender visualization of finger poses. Yes. How well networked, what performance it is achieved on real data compared to the virtual simulated data? Did you use the background from real images like this? Did you mix it with real and simulated images?
Yeah. So we perform experiments in which recognition or testing data were from generated only images, and the training was on real images. We perform also experiments in which training data were from real images and testing data from generated images. Naturally, the best results are if you mixed real images with generated images. This generation approach has advantage because you can generate several poses around the given pose and so on and so on. Maybe in the future we will use also generative adversarial neural networks, previous talk, because here the idea is also but maybe the best approach you will be used if we fuse data generated taken by the camera, data generated on the basis of model, because if you take model, then you can put text on this model and so on and so on. And maybe the third part in the training data will be from generative adversarial neural network.
Well, I said that that is the best model of the world.
Which model?
Your model, deep learning about classification and cancer. I mean, that's the best result. I mean, the best result of this classification.
No,
cancer.
on identification, on identification on this Viper data set. The best or second result. It is result from previous year. This work was presented at Stanford, and this paper was nominated to Best Paper Award. So here is our result.
Okay,
so maybe even it is the best result, yeah.
But have you heard about cognition network technology? That's the company Independence that work in this area. So have you heard about that?
About what? About
cognition network technology, the technology of that was developed also classification and some good. They said that they have the best result in this area, and also that it's patent technology. Yeah.
I did not heard about the approach you taught. So this result is on Viper. Viper, it is say small size or middle size data set. Recently, very big data set for personal identification were developed, and maybe on such last data set, last year ago this result was as you see. Yeah, but maybe it will be interesting to consider your
for the future cognition network technology. Yeah. That's called.
So if you find time, then please send me email maybe with paper or citation then.
Thank you for your talk again. I have a question regarding this cancer recognition. And especially about the validation and about strategy. So basically, I would like to ask, how do you perform this sampling of these patches from this huge gigabyte tile, and then how you do you split? And because as far as I know from my experience, for such, when you have such huge tile, you have really similar textures.
Yes, that is the
and
problem.
And if you will not split it wisely, you will have huge leakage there.
Yes, that is very, very good question. So the problem is here that the texture. As you said, patches have very, very similar textures, and it is not easy problem, in fact. So at the moment, the approach is quite simple. We do not sample patches. We eventually take patches. So it is agreed. Naturally, that it is overlap and so on and so on. And the problem is that we have unbalanced data. Okay? Now we focus on this. Then if we will have some models, then we will generate some probabilistic functions here. Okay? And then we will perform sampling in order to balance more data or something like this. Yeah.
More questions? Okay.
So you said you've been using Viper for the personal identification, and that's a specific data set. But usually in that problems, you are training on some data set, and then in order for the model to work in general case, you need to tune it for other cases. Especially that's a European data set. To work in Asia or Africa, you need to tune the model. But you said that you have a few neural networks simultaneously working with images. Would it be so easy in your case? Would not it be a challenge?
So here is only short summary of the research we have done here. In training, in order to perform a good initialization and so on, we started with data from other data sets. Okay? Like, in order to not start with random weights. Okay? And then it was similar a little bit to transfer learning. The neural network were fine-tuned, for instance, on Viper and so on and so on. So Viper, it was not only used data set, but as I said, this approach focused on a middle-level data set. Recently, EECVC, as far as I remember, data set, very big data set has been developed, and maybe this approach will be not the best one. As far as now, at the moment, they are better, but for small data set, for my perspective, it is quite important, because in typical surveillance network, you have naturally a model which was built on Viper and so on, and then probably you will fine-tune the network, and in my opinion, this approach can be useful. Because this can be trained on, maybe not on every laptop, but this model on Viper. Then you take images from your camera, and then we experimented with such, and it performs quite okay.
More questions? We can take 2 more questions, because, yeah.
Thank you for your talk. So I would like to ask your opinion about like handcrafted features versus learned features. So my question is, from my understanding, if you benefit from handcrafted features, that means that probably you don't have enough large data set to learn them. So like for personal ID, for example, like some techniques like merging different data sets, like hard augmentation, etc. Yeah. It may benefit you, and as a result, for this problem, there are some papers that just use learned features. So maybe just a question, maybe at some point we'll come up with a framework that can just take the data and output the features. Maybe it's already there. Maybe it's like convolutional neural networks and that's it. Or from your opinion, like, could you give an example of the problem where handcrafted features just like will work without anything else?
As I said, this is a fragment of research we are doing. We are doing research on action recognition. One of my PhD students recognized actions of fencer. Fencing is sport discipline, fencing, okay? And in such problem, the problem is even not motion, but the problem is acceleration. And at the moment, no neural network exists to understand acceleration, maybe movement. But as engineers, we understand what is acceleration, yes? And therefore, if you extract or take acceleration features, I give you 1% guaranteed that you obtain better results. Because maybe, I don't know, maybe 1 million of images with data would be needed to learn, to train neural network which will be able to understand the dynamics. That is an example. I can give you more.
But you can embed this into your network.
Yeah. Maybe, yeah.
Okay, I have go into the cancer recognition. I have not a question, like more consideration for you. 2 or 3 years ago, there was a state-of-the-art in cancer recognition and cell recognition.
Yes.
It was named UNet, and they achieved outstanding results. And how can you comment this approach?
Yeah, we also work on this data set, but now we focus on our data set. In my opinion, the previous data set, so here there are several problems. One of them is even the sharpness of the image. If the scanner is not okay, if some errors were made at the stage of preparation of the scan, and so on and so on, then so we are working on our data sets because we are sure that the process is correct. The process in cancer recognition, preparation of scan, and so on is very, very important. In my opinion, not all previous data which were made public, published, it was maybe for benchmarking, but we are interested here in real application. This system probably will work in the future on real data, not on benchmark data just.
So I think that's it. 2 notes from my side. I think Bogdan have very interesting practical results and have a very interesting experience. And my mistake, what I didn't work with him before, because we need maybe to skip like some theoretical part and talk about last part.
No, you wrote me that I should give.
But and you see like you have a question like 10 people asking you about cool questions. So we save it time. And we have very good discussion. So believe me, we have in a Facebook group, and it's so. And second note, I'm very glad what we becoming kind of platform. Very professors from European universities come here, showing some good opportunities to students, to researchers, and I think it's good because we all have for the students it's again here people not only from Ukraine, from different countries, so we can show different opportunities where they can work in academia or in some practical results. So very thank you for this, very thank you for coming here, and thanks for good talk, and thank you for your question. Let's make applause.